Lesson 27 is radical equations and inequalities in context. So this lesson is going to combine 27.1 and 27.2 all into one section just because point 1 is solving and point 2 is interpreting. So it just kind of makes sense to group them together. So example 1, a zookeeper wants to relocate a penguin exhibit. She has located a square of land enclosed by a fence that has a perimeter of 96 feet. The penguins will need at least 500 square feet to live comfortably in their enclosure. Is the square of land she found large enough for the penguins? So use the formula P is equal to 4 times the square root of A, where P is the perimeter and A is the area. So this formula is kind of derived from the fact that you don't need to write this down necessarily, but like for a square, perimeter is equal to 4 times the side length, because you would add all 4 sides together. And then the area is a side length squared, like it's side times side in a square. And if I were to solve for like S in this equation, I would have to square root both sides. So then I would have the square root of A is equal to just an S, and then we can take that square root of A and put it into this 4 like S, and then that's how we get this formula. So the perimeter is equal to 4 times S, but really like 4 times the square root of A in terms of area. Okay, so not critical for this problem to like know where it's coming from, but it's always kind of nice to know where the formulas are coming from. So in this problem, we're given a few key pieces of information. We're given that the like square of land has a perimeter of 96 feet, and that the penguins will need at least 500 square feet to live in comfortably. So that word at least is kind of like, or I guess words, but it's one of those things that should like set off a red flag or should stick out to you whenever you're reading a math problem, because at least means that it's going to most likely be an inequality instead of an equation. So we're given perimeter right here. We don't have anything that specifically says like the area is this, but it says that the penguins will need 500 square feet to live comfortably. So square feet, that's a like unit of measurement for area. Just feet is like a length, so it would be like that. Feet would be for perimeter, and then square feet would be for area. So area is going to be 500. And then that at least is going to help us determine like what our inequality symbol should be. So our setup of our inequality is going to pretty much match the formula that we were given to use. We'll just switch out the equal sign for the inequality symbol. So we're going to start with P is equal to 4 times the square root of A. I'm going to erase that equal sign and switch it out though. So at least means greater than or equal to, like it can be exactly that much or it can be anything more than that. So like if I have, I don't know, at least 5 pieces of candy, then I could have 5, but I could also have 6, 7, 8. I can have anything more than that as well. So at least means greater than or equal to. So I'm going to take out my equal sign and put a greater than or equal to. So now we have kind of like our basis or our template for our problem, and I just need to go ahead and put the perimeter in for P and then put the area in for A. And then perimeter is 96 feet is greater than or equal to 4 times the square root of 500. And then we're not actually like solving for anything here. Like we don't have any unknown variables or anything like that. We're basically just trying to see if these measurements are appropriate for this problem. So meaning like it says towards the end, it asks, is the square of land she found large enough for the penguins? So what that means in terms of math is this inequality true? So is 96 actually greater than or equal to 400 times the square root of, 4 times the square root of 500. So I want to try to avoid just kind of punching 4 times the square root of 500 into the like calculator and just practice like inverse operations to kind of like get rid of the radical and the things that kind of make it difficult to solve without a calculator. So first things first, I can get rid of this 4 that's out in front by dividing both sides by 4. So if I divide both sides by 4, 96 divided by 4 is 24. And then bring down the symbol, keep it facing the same way, and then bring down the square root of 500. And then goal is to keep like simplifying this without using a calculator. So now I can go ahead and I can square both sides to get rid of that radical. So 24 squared, if you have to use a calculator for that, that's totally okay. But it's 24 times 24, which is 576. And then bring down the symbol is greater than or equal to. And then when I square root the 500, that just cancels out the radical. So it leaves me with a 500. And then now, like, everything's kind of simplified and, like, just more straight up numbers, like no radical or anything like that. So I can look at it and be like, okay, is 576 greater than or equal to 500? Yes, it is. So that means that the square of land that the zookeeper found is large enough. Okay, so yes, it's large enough because we kind of put our values into the inequality, simplified, and it was true. And then the next section says analyze the graph to the right, find domain, range, and interpret a point from the graph. So for domain is what are all of the possible x values from the graph. So if I look at the x-axis, it is perimeter in feet. So in the context of this problem, domain is what are the possible perimeters of all these enclosures. So if we look at the graph and we just kind of like disregard the context, if you look at the graph and look like how far it expands, like from left to right, that'll tell you what the domain is because it's all the possible x values, which are how far we go left or right on the graph. So we can see that, the graph starts like about right there. It doesn't go any left from there because if it did, then that would give us negative x values, which would mean negative perimeter, which doesn't make sense. So we're starting at what looks like 0. And then we're going to the right and there's no cutoff. So if there's no cutoff, then everywhere to the right would be infinity. Even if that wouldn't necessarily be possible to have like an infinite perimeter, if there's no cutoff, we just have to say it goes up to infinity because we don't really know what that cutoff is. And then for interval notation for domain and range, we have to use either parentheses or brackets. Brackets are for when we include a point, and parentheses are for when we can't include a value in the domain. So we always put a parentheses around infinity because you can never include it. It's just equal to, or it's not like a real number essentially. And then for 0, we have to think, does it make sense to include 0 in the given context? If we include 0, that would mean that it's possible to have a perimeter of 0, and you can't have a that's supposed to be a square, what the heck? Okay, you can't have a square object with, or really any object, but you can't have a square object with a perimeter of 0. It's not possible. There will always be some sort of perimeter. So 0 is not included, so we put a parentheses around it. And then for range, range is all the possible y values of the graph. So if we look at the y-axis, that is area. And then same thing here. This graph is not going to continue down through here because if it was negative in terms of y, that would mean we have a negative area. You can't have a negative area. So it looks like our range is starting at 0 on the y-axis and it's going up from there. So if it's going up indefinitely, it'd be going to infinity. And then parentheses around infinity because we can't include it. And then same thing here, if you have a square figure, any sort of figure, it will have some kind of area regardless of how small it is. So the area would never be 0, so we don't include 0 in our interval. So we put a parentheses around it. Okay, so we have domain and range, and then the last little part of this problem says interpret a point from the graph. So that just means pick any point from the graph and explain what it means in context. So graph's kind of small, so I'm going to zoom in. I'm going to pick this point right here. And you want to try to pick a point that's crossing through exactly. So I'm going to pick 70 and 300. And you can pick really any point that you want that looks exact. So 70, 300, and then 70 was on the x-axis, and the x-axis is perimeter in feet, and then 300 was on the y-axis, which is the area. So what this would mean in context is that when the perimeter is 70, so when the perimeter is 70 feet, the area is 300 square feet. Example 2, the speed of a zero gravity carnival ride can be modeled with the following function: s equals 3.27 times the square root of r. S represents the speed in meters per second, r represents the length of the radius in meters. If the speed of the ride is 8.63 meters per second, what is the radius of the ride? So in this problem, we're given the speed and we want to find the radius. So we got to take that speed, we got to put it into the equation where s is, and we need to solve for r. So I'm just going to rewrite it really quick. S is equal to 3.27 times the square root of r. That that s is going to get replaced with what we were given for speed in the problem, so 8.63. So 8.63 is getting swapped in for s, and then is equal to 3.27 times the square root of r, and then we want to solve for r, so we want to eventually be able to get that by itself. So if I want to get r by itself, I have to just start canceling things out that are around it, being done to it. So that 3.27 is being multiplied by it. So to undo that multiplication, I can divide both sides by 3.27. So 8.63 divided by 3.27 is approximately 2.64 if we round to 2 decimal places. So we'll say 2.64. And then if you've never seen the little like kind of squiggly equal signs, that's usually what we switch out for if we say like approximately, because I had to round, because it was like 2.63914 and so on, but that 9 rounds the 3 up to a 4. And then dividing the 3.27 by 3.27 cancels it out, so I'm just left with the square root of r. And then now if I want to solve for r, I have to get rid of that radical, so I would have to square both sides. And here's where, if you still have that like kind of big long decimal version of the like 2.64, you can just square that if you want to. That answer would technically be more accurate. But if you don't, it's okay. You can just go ahead and square 2.64. It'll still be close enough to get like a realistic answer. So 2.64 squared is 6.97. If we round up, it was like it was 6.9696. So that 9 rounds the 6 up to a 7. And then on the right side of the equal sign, that radical just cancels out and we're just left with r. So that means that the radius of the ride is approximately 6.97 meters.